Welcome back for the fifth part of this series on building a netcat clone in Rust. This time we're going to add TLS to rcat so that it can talk to applications that encrypt their data for transport. If you're not familiar with TLS, there are lots of great videos about it, and I'll link some in the description for you. It's probably worth having a look at those first, because this video will make more sense having understood that. Adding TLS support is going to require quite a bit of code, so I've made a start installing the libraries we need, grabbing some of their example code that you see here, and generating certificates. I'll show how the certificate generation was done in another video. Let's talk about what's already here and what we need to add. So this is our TLS connect function. It takes a host and a port, similar to what we had previously. It then builds this trust store. This is a list of all the root certificates that the Mozilla web browser trusts. That's what this webpki roots library contains. So that means that when we make a TLS connection, we will trust any root certificates that have issued certificates we're seeing. Then we set up a TLS config. So with safe defaults, that's just the Rust TLS library giving us what we need. We add in the root certificate bundle, and then we say we don't want client auth, so we're not going to authenticate with any servers we talk to. That's something that netcat can do, and something we'll come back to. Then we set up a TLS connector. We prepare the host we're going to connect to. We connect to a TCP socket. That's exactly what we were doing previously, just connecting to a TCP socket. It's the same class. And then once we've connected, we wrap that socket with the TLS connector. So this is initiating a TLS connection on top of the TCP connection. And then we're into a situation where we have very similar code to what we had before. If we have a look at our stream, in the connect function for that, we had this client that was a TCP stream, and we did our reads and writes to it. And then again, that was similar to what we did for the server. So we could copy paste this code again over to the TLS version, but we've already done a fair bit of copying, having it in 2 places. We'd end up with it in 4 places here. So it's time to figure out how to refactor that stream code for the read write. So let's go and do that first. We'll start in a new file called common, because this is something we're going to reuse a few times. So let's put together a skeleton of what we'd like to have, which is an async function called readWrite that takes a reader and a writer of some type. So we don't know what these types will be yet. Let's make that function generic with those types. So we're telling Rust that this function can be called with 2 different types that are a reader and a writer, and we've not told it anything about what those types are yet. So we'll place some bounds on those types in a minute. And then to fill in the function, we want to take this content here, which is the thing we're trying to extract, over to here. And at the moment, this won't build. The compiler won't know enough about what R and W are to be able to decide whether it's safe to pass a reference off to copy. So to get an idea of what bounds we should put on R and W, a good place to start is to look at what copy takes, because that's doing a similar job to this function. So if we have a look, this is accepting, again, types R and W, reader and writer. The reader is async read, unpin and sized. So we won't worry too much about what these are. Let's just copy them back to our function. And we'll need to import those. And at that point, we can tell that we're not quite happy. Size is not satisfied. R does not have a constant compile time size. So that we can fix by requiring sized, not making it optional. We're also going to need a few more traits. We could go around the loop on the compiler, but we're going to need send as well, because we are not taking references here. We are passing the reader and the writer to this function, and it will then manage them for as long as they live. So we're allowing the types to be sent from wherever the function's being called to this function, and this function will then own them. So that's a good start. Let's go back to our TLS and try calling this function. Read write, and we need a reader and a writer. So to get hold of that, we need to do similar to what we did before, split up our stream. So let's go ahead and do that. So let reader writer equal to split on stream. Good. So that gives us a read half and a write half of our stream, and we can pass those to our function, reader and writer. And let's see what the compiler says. We'll build the project with cargo build, and it's not happy yet. So it's complaining that W doesn't live long enough, and I think it's saying the same thing for R. Yes, it is. So we've got the same error twice, saying that the type doesn't live long enough. We've not told the program how long to expect that thing to live. So we've transferred something into our function, we've taken ownership of it, and then we're going to move it again when we pass it off to Tokyo to be used as a read-write stream. And Rust can't work out how long it's going to live. To be able to give us the guarantees that it does, it needs to know this. So it's recommending that we add the static lifetime. Let's copy that and go back to the code to see a bit more about the problem. So we know we can fix this by adding a static lifetime here, but just to iterate again about what's going on here, we're taking a type not by reference here. We're being transferred a reader and transferred a writer. That's why I've added this send trait. So at this point, when this function gets called, it owns a reader and it owns a writer. But then we spawn a job on Tokyo, which moves, but it's only taking a reference to those. So nothing else can use them at the same time, the reader and the writer, but they are being used, not owned by that Tokyo job. So this function's still responsible for them. So what we have to say here, by making it static, is these things that are being passed in, which we know are sockets, are going to live as long as the task needs. And in this case, that should be true. Our program isn't going to shut down the sockets we've opened. The only way that they'll shut down is if the program gets shut down, or if the other end of the connection closes, at which point this will all shut down neatly anyway. So normally to be avoided, the static lifetime, but in this case it's valid. We expect our objects to live as long as the program does, and as soon as anything closes, the whole program's going to shut down anyway, so perfectly reasonable to say that these variables won't go away. So let's see if that's made this build. Just to make sure we're on the right track, we'll check that it builds. Now we've applied the suggestion that Cargo gave us, and it does. So that's looking good. Let's go back to our code and see what else we need to add to this TLS connect function. It's looking pretty good. We've got our socket open. We've made a TLS connection over that socket. We've got our reader and our writer, and we've set them up to behave the way that they did when we were using plain text. The only thing we haven't dealt with is trust. So we've got this root bundle of certificates, which is great if we're connecting to a big website that's got a certificate issued with a known provider. But for us, in this situation, we're adding certificates locally. So we've got a CA locally, certificate authority, that this bundle won't know about. So we need to support adding that extra certificate to our trust store, so that when we try and connect to ourselves, when we're running an rcat server, we don't have issues with certificates not being trusted. So to do that, we'll need to add a new parameter to the command line, and we need to accept it here. So we'll take that as a CA parameter, which will come in as optional of string, which is the path to the file. And then we want to add that to the bundle. So the first thing we want to do is extract from that option to make sure it's there. So if let sum CA equals CA. So this is a pattern matching let if. So we're saying declare a new variable called CA, but only if the thing on the right hand side can be pattern matched to the left hand side. So it's the sum variant of the option enum. Then once we've got that, we can load the certificates from that file. So we'll call our load certs function. This is something that's been taken from examples. It's not something I've written. We'll construct a new path from the CA. And then we want to loop through those certificates, because there could be more than one in that file being passed if there's a root CA chain. Call that cert. And then we can do root cert store dot add the certificate. And then we want to handle any errors. For now, we'll ignore the internal error and we'll just return one of our own. So we'll assume that there was some problem with the file itself. And that's not quite happy yet. So you can see we've got a VEC certificate here, which is reasonable, but I think we're not handling the error from load certificates. That's right. Okay. So we load the file up, we split it if there are more than one certificate in there, we loop through the certificates, and we add them to our cert store. So that should be everything we need to do for the client side of this. So let's give that a test. We're going to run that and try and connect to google.com on port 443, which is its secure TLS port. That's what you'd be connecting to if you were using HTTPS to connect to Google in the browser. Let's see what happens. And we've made a mistake with the code. So it's saying we're missing a semicolon. And there's also a complaint about a result here. So let's jump back to the code and see if we can fix that. So we'll start by adding in the semicolon that it was complaining about. And now we're seeing a warning, which is unused result that must be used. So we've forgotten to bubble the error up here. And because we'd missed the semicolon as well, it didn't know that we didn't mean to return this. So fixed. Let's go back and see if that builds and runs now. Let's rerun that same command. Try and connect to Google on port 443. And this time it looks good. We've got an open connection, and this isn't closing. So let's try and send some text to Google. So we'll send the start of an HTTP request, and then some nonsense, and see what happens. Cool. So we get back an error saying the requested URL was not found on the server, and it's closed our connection. So basically a 404 page, which is entirely fair because we gave it nonsense. But it's working, which is great. So now we can think about building the server side of this TLS component. Quite a lot of the code on the server side is going to be familiar to us. So either from the function that we just looked at for the TLS connection, or from previous videos of setting up listener sockets. So first we set up our root bundle, then we build our TLS config, then we set up a TLS acceptor, and this is doing effectively the opposite of what our TLS connector was doing in the function above. We set up a TCP listener. That's exactly the same as previous code. We bind to an address and wait for connections on it. We accept the first connection we receive. Then we wrap up that socket that we received with our TLS acceptor. So that's going to effectively add TLS to that socket. It's going to start communicating with TLS messages over that socket. Then we split up our stream and we hand it off to read-write. So this is looking pretty good, but there are a few things we need to add. The first one is adding in the root certificate that we're using. So similar to what we did in the previous function, or exactly the same actually. We're going to copy paste and tell ourselves that we shouldn't while we do it. So that sorts that out. The other thing we need when we're a server is to present a certificate. So matching what we did on the client side where we said don't send any authentication, we're not going to expect any client authentication on the server, but we do need to present an identity. We need to tell the client who we are. So we're going to load certificates. We will do load certs from a path, which is coming from parameters to this function. We're expecting a certificate to be provided. And if there are any errors, we'll bubble those out. And we'll assign that to a variable called certs. And then for this side, because we're actually doing the encryption on this side, we also need a key. So the certificate is the thing we serve up. That's what connections use to verify who we are and decrypt any data we send them. But to do the encryption on this side, we need a private key. So we will load keys. Again, we've been provided with a path for that, which is just this key here. Bubble any errors up and assign that to a variable. And then we can add this to our TLS config. So there is a method provided on this builder, which is with single cert. And we'll provide it with our certs. So we can provide multiple certificates in here. In our example, we just have one. This can accept it. It can accept a certificate chain. So we could use a bundle here. We could provide both the server certificate and the root CA in the same file and not have to write this piece of code. So that will probably be a good tidy up, but for now, this works. And we'll just correct that to be as str, as string. And then we'll grab the key for our server as well. So we'll do keys.remove. and take the first key out. And that should be everything we need to do. We should now be able to start this up and connect to it with our client. So let's see if that works. So here's the server command. The first part should be familiar. We're going to cargo run serve on localhost port 2323. That's the same command we've been using in previous videos. But now we're going to also provide the pieces we've just added to the server function, which is the CA certificate, the cert to use for the server, and the key to use for the server. And these are the files that have been generated for use for this program. So let's run that. And that's started up and listening on localhost 2323. The client command is similar, so we're going to start it up on localhost 2323 and use the same CA that we use for the server. And we're connected. And we should hopefully see text coming back and forth. We do. Good, so that is working. It's hard to see that it's encrypted because it behaves exactly the same as it did before. The TLS is effectively transparent. We think it's working because we connected to Google on a secure port, but it would be really good to see this working in a way that we can test it properly. So how could we break this so that we can see it working? One way to break this would be if the connection from the client didn't trust the server's root certificate. So if we didn't have this certificate added here. So let's comment this code out for the moment. And we'll try the exact same example again and see what happens. So we'll start the server up with the same command we just used. And that should work. Good, so we're listening on 2323 like we were before. And then when we try and connect with the client, this time, even though we're providing the CA on the command line, the program won't load it. So when we start our handshake, when we start communicating with the server, it won't understand or won't recognize the server's root certificate, therefore it won't trust its server certificate, and it should reject the connection. So let's see what happens. Cool. Invalid peer certificate contents, invalid peer certificate, unknown issuer. So that is the error code that Rust TLS is giving us for, I don't know what this CA is, I don't know whether to trust this certificate, I don't know who it was issued by. So that is really good. We're now fairly confident that this is using TLS on the client and the server side, and that is it. That is TLS implemented for rcat. Now we could add some more to this. The original netcat does things like OSCP certificate checks, so checking that certificates haven't been revoked by the issuer, and it can also do some other fancy things with verifying and dropping connections, but this is what we care about building. How do we get TLS involved? So we will pause there with the TLS journey, and then next time we're going to move on to something slightly different, which is another feature of netcat, to be able to launch a program on the server whenever a client connects. So join me next time to see how we're going to make that work.